All right. This is our favorite time every single week.
That's right.
It's to show and tell.
This is when people show us cool stuff.
Yeah.
We just get to like sit back, relax, fall
Yeah.
off our chairs.
Look at all the cool projects.
Real cool projects.
People around the world.
Everyone invited?
Yeah, we have some folks waiting right now. We're going to start with some Adafruit team members, and then we got some other people. Don't forget, every week, 7:30 p.m. Eastern Standard Time, anyone who's on the show and tell gets an As Seen on the Show and Tell sticker.
Yes.
But we will...
you can get as many stickers as you want, and it can show up as many times as you want. We have people who show up like every other week.
That's fine.
Totally cool.
That's fine. Gives you motivation to do the project.
Yeah. You have to rush to finish it.
This makes me come to work on Wednesdays for sure.
Yeah. We should say like a lot of people are going to who buy free stuff are going to Burning Man. We'll see if they show up like next week, which is like the last week.
They'll have all their stuff.
And or just end up using the stuff in the desert.
Yeah. Okay.
It's like a big show and tell. Okay.
First, Tony from Adafruit Northwest.
Hey. Yeah. Yeah, I've got some CC3000 stuff. So last week I went through and cleaned up a whole bunch of bugs and integrated some pull requests and things that have been hanging around for a while. And so there's some cool new features in the CC3000 library. And I'll show one of them off real quick. It's basically a real simple web server. And yeah, here's the hardware. It's real simple. We've got the CC3000 on a breakout. And there's actually a DHT temperature humidity sensor attached to it. And it's connected to my network, so I'll screen share real quick to show my web browser, and we'll hit this thing with a request. Do you see the website?
Yeah.
Okay, perfect. So my CC3000 on the left here, this is the serial output from Arduino, and it's connected to my network, so if I hit the address of my CC3000, this is just the IP address that it's been assigned, then, oh, hello world, awesome. So it's telling me here's the path that I've accessed. And you can see a little bit of text went by. That's just telling me that someone connected to the server. And so I can change the path. I can say like /Adafruit, and it's just going to echo back what my path is. And the sketch is real simple. So it's all just in a single example. It's actually not in the library. It just uses the server in the library to power this. And so it's just parsing out the command that gets sent to it. And you can actually, in the sketch, do a little bit more parsing. So I added in some logic. If I go to /DHT, then that just took a sensor reading. So yeah, it's about 78 degrees or so. So it's real simple, real straightforward to use. The code, I won't go through all here, but it's just in this example, it's called HTTP server. So if you grab the latest version of the library, you can take a look at this. It's not the best server, like you're not going to handle multiple requests at a time. Arduino really can't handle concurrency and stuff like that. But if you just need like a simple API to read a sensor, maybe return like a JSON formatted result, you could do it here pretty easily. Just change around the code that you're sending back.
Okay. Awesome.
The other real quick thing too is the main client class in the library. We integrated a poll that adds client support, and so that basically means that code that uses the Ethernet shield is much more easy to port to use the CC3000 code because they use the same base classes. So it's not a direct port, like you still have to call the connect function and get the client back, but once you've got that client object, you can pass it off to anything that works with the Ethernet code, and in theory it should work. I've tested a little bit and it seems like it works, so give it a shot, and if people see issues, definitely go back to the GitHub repo and open them up.
Handy, because there's a bunch of projects that people did and they probably want to eventually migrate them to like a CC3000.
Exactly, yeah, so it's a lot easier to do that.
Okay.
All right.
Thank you so much for putting in that effort. You've been doing an excellent job taking care of that library. It's well loved by many people.
Yeah.
No problem, yep.
All right, thank you so much,
Thanks, Tony.
Next up, John Pedro, hello, Adafruit, Southeast.
Hey guys, how you guys doing?
Good. What you got going on this week?
Yeah, happy Wednesday.
This week,
Whoa!
got some big.
A giant bucket.
Hi, giant buckets.
This is fantastic. This is one of the scariest things that came through like on Instagram, because like everybody stopped and they're just like, oh my god, I know exactly what that is.
Yeah, so last week Lamar was like, why don't you guys make a Daft Punk helmet? Okay, cool. So,
I was going to say wait like maybe until Halloween, but you couldn't wait. You just went.
No.
Time like the present.
3 days to print. You got to start now if you want this thing.
It'll print out. It'll be done on October 31st.
It does. It takes a long time to print out.
Oh my god, yeah. If you fail once, you got to get a whole new spool because you got to start all over. You're not going to have enough.
Yeah.
So we got that. Noah worked on some cool 3D printed UV nail cure that'll be coming to Wearable Wednesday near you.
Yeah. This is a really cool project. It came in the mail today.
We're going to really focus on sustainability. We have a lot of prints that we do, and a lot of them, unfortunately, don't come out as you want it because you're prototyping. You want to make things really good. So recycling your prints to make DIY filament is pretty much a big deal to us, and we're really happy that we're finally doing this after maybe a couple of years of failed prints.
Yeah.
And you've saved all the plastic, right? Like you have a lot of it.
Oh yeah. It's all sorted. It's all like by category, color, shape.
And then you had to go to like Sears and get a wood chipper or something. That's great.
Yeah. So it should be an eye opener for like schools and maker spaces. What are you guys doing with all that stuff? You just throwing it away? Recycling centers don't take this, so definitely an eye opener. Cool episode to check out. And little sneak.
Also useful if you're in an area that maybe you can't get filament. Instead of going to the store, you can just recycle filament, or maybe even make your own filament.
Yeah.
I mean, what you've got there is not that much different than what the factories have.
Yeah.
It's not going to be the nicest filament, but maybe it's better than going to the store 3 in the morning.
Yep. Yeah, with some practice, you'll get some consistent diameter. And a big shout out to Tony for a future episode we're working on here. Nice, cute little computer.
Okay.
We are off with that. Don't forget, everybody, check out 3 Thursdays.
That's right.
Thursday, 3 p.m. Cover this more. Follow us on Instagram, Facebook, Twitter.
Yeah, it looks like you guys.
We're black. It's cool. We're like all black. So.
There's 2 cameras here.
Okay.
Yeah. I know exactly how you feel. I got 8 cameras.
No, we have a lot of cameras.
Yeah.
So,
for all the folks out there who want to see more 3D printing, because there was a lot of requests, we have an entire show now. So tomorrow, 3D Thursday, 3 p.m., you'll see these guys and Matt and more. So okay. Well, thank you, Noah and Pedro. Good stuff.
All right. You guys are amazing. Thank you so much.
All right. Next up.
Okay. Next up, Janin.
Welcome back.
Hello.
We missed you.
We missed you.
So there's actually a reason.
Wow, this is sweet. Like stations and.
This lab?
Yeah.
So this is our project lab, also known as the surface mount soldering lab.
Okay.
So there are a couple of soldering stations here and some equipments. And I'll be taking here next semester. So.
That's right.
All right. So this will be your backdrop for your projects now.
Well, okay. So there's actually a reason why I designed that 16x8 LED matrix breakout. Do you want to take a guess?
Yeah.
Pocket Tetris.
Here we go. Tiny.
Whoa! I'm so good! I mean, what else would you make?
Okay, so here is the tiny Tetris. And also remember my old Tetris.
Yeah.
That's also here. So on this new tiny Tetris, the enclosure is all laser cut in our machine shop because I wanted to experiment with different machines, and also used a lot of the it's called the 3D engraving feature on the laser cutter. So it cuts with this according to the grayscale.
Yeah.
And that's how I did the countersink of the screws.
Oh, that's nice.
And also the area around the joystick to allow it to move. And on the bottom, it's a little too dark. Hold on. Let me adjust the light.
Yeah. For the micro USB jack.
Yep, micro USB, and there's a 6-pin programming header for the trusty USB Tiny. And so for the software, it's, well, here we go. I just powered it on, and here you can play Tetris. If you scroll to the right, you can play Snake, and then there's another program called Paint. I don't know if the Paint or Draw, so you can just draw or clear dots on the display. So yeah, I mean, just go with the Tetris first. It's basically the same code as the old Tetris, and this is actually the first time I've ever written any C++ code. So all of these, each one of them is a C++ class. So the Tetris, Snake, and Paint, and also there's another class for the Holtec LED display driver. So that's, and I just used a simplified version of your library.
Yeah.
Yeah, because I don't really need all that functionality. So yeah, that's Tetris. And if you want to switch to Snake, you just press the select button. And okay, so here on the side we have 2 more buttons. It's all on a laser cut on the side. So it's currently it's for adjusting brightness. So if I keep holding
that's cool.
Right.
The brightness increases, and then now you can see the brightness decreases. So if I hold select and press one of the buttons, it jumps to Snake.
Okay.
And I can play Snake, and then do it again. I can play Paint program. I just so I can move the cursor with the joystick, and use the select button to, draw this stuff. Oh, hold on. Let me just draw something real.
The only thing you're missing is our new Fona device, and turn that into a phone.
I actually got the Fona, both the Fona and the 2.8-inch capacitive touchscreen.
Yeah.
That's what I'm trying to combine together and make a.
Oh, great.
Yeah, I mean, like, it's a lot for an Arduino, but a bigger chip maybe.
This laser cut case is great.
This is beautiful.
Yeah.
It's a 6-bit design.
That phone, I was like, I bet he's making a pocket Tetris.
Right. And then, so if I hold the select button for 3 seconds, it just, clears the display. And also, the last feature I want to talk about is this. Here's also a red one. So if I just keep it on, because in the software right now, I set the threshold of the, the voltage level for it to turn off to be very high. So that's when it automatically turns off.
Okay.
It's basically the same circuitry as the push button on-off switch that you guys carry.
Yeah.
And then also, well, aside from that, there's a boost converter there that converts the voltage, and also the microcontroller is the 32U4, same as the Leonardo. And also this one, unfortunately, I'm missing a battery for this one. So it's supposed to be 4 different colors.
Collectible.
Right. Right.
iMac style when they launched the iMacs. That's great. Well,
awesome.
you get as many as seen on the show and tell stickers as you want. You can have one for each or whatever you'd like.
And email us also because we're going to send you a whole bunch of these matrices.
Yeah.
We
have a little box ready for you.
We have a box, so yeah.
Just put attention, Phil, when you email support@adafruit.com.
Sure. And also I wrote a very detailed blog post about this. I'll put it in there.
Right.
Yes, thank you.
One of the things I like Pocket Tetris is you get a pocket reminder that accomplishes disappear and mistakes pile up. That's what Tetris is. you solve it, it goes away.
Eventually your mistakes pile up and you die.
Yeah.
Morbid.
It's a cool, that's what Tetris is. It's cool. It's a good reminder.
Okay.
But if you're fast, you can keep going. Okay, next up.
Let's play email game. Same thing.
All right.
Andre.
Andre was next up. Andre.
Hello, I'm back.
Welcome back.
So after 2 weeks ago, I did some troubleshooting for my turret, and my sonar sensor was shorting out on itself. And so I removed it completely and just made it controller operated, just with this small breadboard with 3 buttons, left, right, and fire.
Yeah.
I still have the gigantic magazine, if you can kind of see it.
Good.
So, let me rotate the laptop. Okay.
It's going to happen. I can tell.
Alright, so you can see the top kind of off to the side. What are you guys seeing?
Oh yeah.
I see some sort of like a vase thing with a hole in it.
That's you put a little fire in there.
Oh, sorry.
Yeah.
I don't have a backyard.
Yeah.
And some trees. They're really lovely trees.
Alright, so I mean, hopefully you guys are seeing like just like some cups standing up and.
Yeah.
Oh yeah. Those are blue cups.
This is like Yoda's backyard.
Okay.
That's where he cooks the.
Sorry.
Yeah. So I'm going to be shooting at those with the turret. I'll turn this so then you can see the turret.
Okay.
See how well can you see it?
Yeah. Yeah, I see it. Looks dead.
All right. Gotta plug in the battery. And plug in the Arduino power supply. Load the mag.
Wow.
Whoa. Scary.
Did you hit the cups?
Looks like I missed, but the mag wasn't auto winding.
Okay.
So I had to change the settings. So let's see if I can get.
Yeah, point it that way and then see if and then fire again.
All right.
This is how all war should be fought.
With like Arduino code?
With Arduinos and nerf.
Think like.
Did the battery seriously die? Oh my god.
Oh no.
Oh, I hate when this happens.
All right.
We have to have a peace treaty.
Yeah. Here's the thing, Andre. Do you want to come back next week and?
Maybe third time's the charm.
Yeah.
Yeah.
These cups are not going to stand a chance next time.
They have to just like deal with the fact that
they've been warned. The cups have been warned.
They've been warned.
Okay.
You should just leave them there. Leave them there.
Yeah.
So they know it's gonna
All
happen.
right, Andre. Come back next week.
It's gonna be epic.
All right.
I mean, we heard it.
The victory will be so much sweeter.
That's
Don't worry.
right.
Okay.
Yeah.
All right. Next, Adam.
Adam.
Hey, Adam. How's it going?
Adam.
Hey guys,
Hey.
Yo.
what's up? So I've got a very large LED matrix that I built for the North Carolina Maker Faire.
Good.
Let me see if I can switch cameras and show you guys.
Wow.
Can you see that now?
You weren't kidding.
That's big.
So, so it's 24 by 24 pixels. Each strip on there is half a meter long. I basically realized that the manufacturer I often buy them from in China manufactures them as half-meter segments and then solders them together, so I got them to just send me the half-meter segments.
Mm-hmm.
And then arrange them in a grid on a sheet of acrylic. They're the LPD 8806 strips, mainly because originally I wanted to run it directly off of a Raspberry Pi, although I've since upgraded to running it via serial bridge on my computer because the Raspberry Pi didn't quite have the power to generate the animations. I actually made the power buses out of, I don't know if you can see those, out of copper tape. And then it's just all hand wired. I was going to do like half-meter long PCBs and get them printed at OSH Park, but it was going to blow up my budget a little bit too much.
Yeah.
For something that big. If I can get the light.
Yeah.
All right, let's blast it.
Fire this thing up.
All right.
All right.
Wow.
Whoa. And an Adafruit logo. That's great.
Epic.
Oh, you got
That's
you got the
fun.
matrix thing going on. This is cool.
Yeah, it's gone through a little bit of demo code.
Oh, that's nice.
Few of the animations I've programmed for it.
Great.
And it's all running.
You can see your webcam is freaking out a little bit. Your webcam's like, no.
Yeah, it never quite knows how to focus on it. I mean, when I do real videos of it, I have to use my DSLR so I can do a fixed focal length.
Gotcha. This is really nice.
This is beautiful.
Thank you.
Nice work.
And what was your self-imposed budget for this to build this?
Probably about less than $300.
Okay.
I think I came in around $250, and that was mostly the strips themselves.
That's really good.
But then, it was 4 days of soldering for the most part, and being really finicky and laying it all out.
All right, this is fantastic.
Yeah, it's actually running off of I think there's a couple of the Adafruit Learning posts that link to my old RPI LPD 8806 Python library.
Uh-huh.
And it's running off of a heavily modified version of that, which I've updated to support matrices natively.
Very cool. Well, congratulations, Adam. You get an as seen on the show and tell sticker that will not be visible if you turn it on.
You put it on the back
Throw it on the back or something. All right.
Yeah.
Thank you so much.
I thank you.
If you take photos or have a poster or anything, also let us know. We'd like to
Don't
post
log
it
it
up.
up.
Oh, yeah, we'll do. And actually, there's also I put up a post on my website, maniacallabs.com, that has build details on how I put it together and what I used and whatnot.
Oh,
Sweet. Yeah, so email us.
I think we've covered Maniacal Labs before a bunch of times, right?
A couple times, yeah.
Yeah, you have great stuff.
Okay, send us
Thank
this
you.
link and we'll
Yeah.
post it.
Okay.
Send us the link and we'll block it
Yeah.
out.
We'll do.
I
Thank
need
you.
an seen on the show and tell sticker too.
Yes.
Okay, we're gonna do Michael, and then we're gonna wrap up with Nicholas. Full house tonight. All right,
Yeah.
Michael. Hello.
Hi, how are you? Can you hear me?
Yeah.
Ooh.
Okay, so I've got two things real quick. I have an update to something that I showed off in February on here, which is a handicap accessibility gaming controller. And I made the PCBs much smaller because the original ones were really big and people were complaining about them. So I made them much smaller, and they're much cheaper to make, and I'm selling them on Tindy now.
That's good.
And then this is a robotics controller that I've been working on with a Raspberry Pi header on it. And my friend Mike and I have been working on making OpenCV work much better on the Raspberry Pi. Because when you try to get it to detect things, like right now we're trying to make it determine if it's staring at a bottle of Coke or a can of Mountain Dew. And it has a lot of problems figuring that out in a reasonable amount of time.
Mm-hmm.
So we're trying to make a robot that will find the soda that is delicious.
So is it the color that it's having a hard time with, or what can it?
So Mike's more into it than I am. Basically, the way that simple CV does it is it compares two images, and that takes way too much processing time to actually do it. And Tony had suggested in, I think it was a learning post, that you should only do it every X amount of frames. But if you're looking for something that needs it and you need it really fast, you can't wait 5 seconds to see it. So right now we're looking for a histogram instead of the actual image.
Okay.
Yeah, and we got the frame rates closer to 25 now.
Yeah, pretty good.
Very cool. The next challenge after that is determining Dr. Pepper versus Mr. Pibb or Mountain Dew versus Mellow Yellow. Very
Mellow
hard.
Yellow.
Oh, you're going to confuse it now.
Yeah. Very
Yeah.
difficult.
If you get that working, you can like submit it to SIGGRAPH. All right.
All right. Well, thank you so much,
Thank
Michael.
you,
And email
Michael.
support@adafruit.com, and we'll send you out as seen on the show and tell sticker.
Thank you.
And last
Okay.
up before we head off
Last
for the
but
night.
not least,
Hello,
Nicholas.
Nicholas.
What's
What you got
up?
going?
Hey, so I got two things. This first, can you hear me? Oh, okay. Okay.
Yeah.
Sound great.
Okay, great. This is a USB Tiny clone done SMD style. The improvements, I started sort of with the design of the Pocket AVR programmer from SparkFun, but they have a bug in theirs. They have a pull-up resistor on the buffer enable line, but that causes programmer power to leak from USB over to the target. Even if you turn target power off, it's just target power through a 20K ohm resistor, which is no good. People have commented that that's bad for 3.3 volt devices that you're trying to program. So this fixes that. I put a blocking diode to make sure that doesn't happen. Also, I put a 3.3 volt LDO on here, and you can switch the target power between 5 volts, 3.3 volts, or off, which means that the target is self-powered. And I'm powering the Tiny from the 3.3 volt LDO, so it actually can program things, I imagine, all the way down to 1.9 volts. So it's a power agile ISP programmer for every voltage range that of AVR chip that you can get. So that's thing number one. That's somewhat less interesting, I guess. This is the big deal. If you look on the back of any wall clock that's been made in the last 30 years, they have this same box, and they all are made by different manufacturers, but they all have the same guts inside. There's a gear train and a Levette stepper motor, and if you take the board off of that and cut all the traces and then solder wires onto them, you can hog tie it to your own controller board and make the clock tick any way you want. So what I've got here is, this one is an arithmetical ticker. It ticks once a second, so it still keeps accurate time, but it picks a random tenth of a second to do the ticking on. So it will it's an arrhythmic clock. It doesn't have a rhythm to it. I have 8 different firmwares for this controller. I have a Martian clock, so I can make a clock that ticks in Martian sols, which are 39 minutes, 36 seconds longer than usual per day. I have a Vetinari clock. If you're a fan of Terry Pratchett's Discworld series, I have Lord Vetinari's clock as a firmware load. I have a lazy clock. It picks a random number of seconds and then does all the ticking up front and then just stops. So I have, most of them are novelty clocks. I have one that ticks 10% faster for 12 hours and then 10% slower. You give that one to your boss.
Yeah.
It makes the day fly by. So I've got various firmwares. This is I sell these on Tindy, both the controller boards, so you can retrofit your own clock, or I'm also selling complete movements that you can stick in if you want to do your own clock making.
Oh, that's funny.
With various styles of firmware for it.
Okay.
That's fantastic. Well, you can put the as seen on the show and tell sticker on.
Yeah, this is my lab clock, so definitely a sticker's going on here.
Yeah.
Okay.
You could just have it go from 7:30 and then just have it like fly over back to 7:30. It's show and tell all the time
All the time.
with the special show and tell clock. Well, thank you so much, Nicholas. Cool projects
right.
tonight, everybody.
Great timing. We finished, and we even have a couple minutes to set up.
Yeah.
for the show.
All right. So don't forget, every single week, 7:30 p.m. Eastern Standard Time, go to
PlusGoogle.com/plus-and-Adafruit.
Yeah, you read my mind. And you just have to post it in a comment, usually on Wednesdays. We even post it up sooner, and then we add you to the show and tell circles. Anyone on the show and tell gets as seen on the show and tell sticker. And you know,
Jen gets even more stuff.
I looked. We've been doing this for 2 years.
Great.
Yeah, we started June 2 years ago, every week, and now it's on Wednesdays. So 2 years, and Ask an Engineer 5 years, and then Wearable Electronics was 1 year.
You can watch my hair change all the different colors.
Yeah,
No, it's the
you
same
can watch
color.
mine go gray. So every year I get grayer. So
Yeah,
okay.
you look like the cool,
Yeah.
like evil guy stripes.
Yeah. All right.
Sophisticated.
So, sophisticated. All right. So we'll see everybody on Ask an Engineer in 5 minutes. Bye bye. All right. Thanks everybody.